Hello friends, in this video lecture I will be discussing about some numericals on bomb calorimeter. Let us discuss some problems on bomb calorimeter. In this problem, the formula used for GCV is given by W plus small w into T2 minus T1 into S divided by M, and the formula used for NCV is GCV minus 0.09 into percentage of hydrogen into latent heat of steam. So these two formulas we are using in almost all the problems. So first let us start with the first problem of this kind. On burning 0.83 into 10 to the power minus 3 kg of a solid fuel in a bomb calorimeter, the temperature of 3.5 kg of water in calorimeter was increased from 26 degrees Celsius to 28.7 degrees Celsius. Water equivalent of calorimeter is 0.385 kg and specific heat of water is 4.187 kilojoules per kg per degree Celsius. Latent heat of steam is 2455 kilojoules per kg. If the fuel contains 5% hydrogen, calculate GCV and NCV, that is gross calorific value and net calorific value we have to calculate. So first of all we have to write the given terms. So W is nothing but 3.5 kg. So W is nothing but weight of water taken inside the calorimeter. Small w is given by 0.385 kg. Small w is nothing but water equivalent of calorimeter. Next, T1 degree Celsius, that is T1, which is nothing but 26 degrees Celsius. So T1 is nothing but initial temperature. T2 is nothing but final temperature, which is given by 28.7 degree Celsius. So M is 0.83 into 10 to the power minus 3 kg, that is mass of the fuel. S, that is specific heat, is given by 4.187 kilojoules per kg per degree Celsius. Lastly, the L. L is nothing but latent heat of steam, which is given by 2455 kilojoules per kg. So after writing the given terms, we have to write the formula used for GCV. The formula used is GCV equal to W plus small w into T2 minus T1 into S divided by M. So we have to substitute the given terms into the formula, that is 3.5 plus 0.385 into 28.7 minus 26 into 4.187 divided by 0.83 into 10 raised to minus 3. So after substituting, the answer what we are getting for gross calorific value is 52,915.10 kilojoules per kg. So kilojoules per kg is nothing but the unit of calorific value. So once we are getting the answer for gross calorific value, we have to go for net calorific value. The formula used for net calorific value is NCV equal to GCV minus 0.09 into percentage of hydrogen into latent heat of steam. So you have to substitute the given terms into the NCV formula. So we are getting 52,915.10 minus 0.09 into 5 into 2455. So we are getting the NCV as 51,810.35 kilojoules per kg. So this is nothing but the net calorific value. The final answer for gross calorific value is nothing but 52,915.10 kilojoules per kg, and for the net calorific value is nothing but 51,810.35 kilojoules per kg. So this is the answer for the given problem. Next problem. On burning 1.15 kg of a coal fuel in a bomb calorimeter, the temperature of 3.5 kg of water in calorimeter was increased from 26.5 degree Celsius to 28.5 degree Celsius. Water equivalent of calorimeter is 325 gram and specific heat of water is 4.187 kilojoules per kg per degree Celsius. Latent heat of steam is 2458 kilojoules per kg. If the fuel contains 4% hydrogen, calculate GCV and NCV. So first of all, here also we have to write the given terms. Capital W, which is nothing but weight of water taken inside the calorimeter, which is 3.5 kg. Small w, that is water equivalent of calorimeter, which is nothing but 0.325 gram. T1, that is nothing but initial temperature of water, 26.5 degrees Celsius. T2, that is the final temperature, 28.5 degree Celsius. Next, mass of the fuel M, which is given by 1.15 kg. Next, S, specific heat, which is given by 4.187 kilojoules per kg per degree Celsius. Next, L, latent heat of steam, which is given by 2458 kilojoules per kg. So after writing the given terms, we have to write the formula to calculate GCV. The formula used is GCV equal to capital W plus small w into T2 minus T1 into S divided by M. So we have to substitute the given terms into the formula. 3.5 plus 0.325 into 26.5 minus 28.5 into 4.187 divided by 1.15 into 10 raised to minus 3. So we are getting the gross calorific value answer as 27,852.66 kilojoules per kg. Next, the formula used to calculate the net calorific value, that is NCV, is given by GCV minus 0.09 into percentage of hydrogen into latent heat of steam. So NCV equal to 27,852.66 minus 0.09 into 4 into 2458. So after substituting into the formula, we are getting NCV value as 26,967.37 kilojoules per kg. So this is the NCV value. So GCV value is given by 27,852.66 kilojoules per kg and NCV what we calculated is 26,967.37 kilojoules per kg. Third problem. On burning a coal sample in a bomb calorimeter, given capital W, which is nothing but weight of water taken inside the calorimeter, which is equal to 2.35 kg. Small w, which is nothing but water equivalent of calorimeter, which is given by 0.45 kg. T2 minus T1, that is delta T, rise in temperature, which is given by 3.2 degree Celsius. M equal to 0.85 into 10 raised to minus 3, where M is the mass of the fuel. S, that is specific heat, which is given by 4.187 kilojoules per kg per degree Celsius. Next, L, which is nothing but latent heat of steam, which is given by 2457 kilojoules per kg. Next, the percentage of hydrogen is given as 2.5%. So, to find the solution for this kind of question, first of all we have to write the formula to calculate GCV, which is given by GCV equal to capital W plus small w into T2 minus T1 into S divided by M. So, you have to substitute the given terms inside the formula, that is 2.35 plus 0.45 into 3.2, which is nothing but T2 minus T1, the rise in temperature, into 4.187 divided by 0.75 into 10 raised to minus 3. After substituting to the formula, we are getting the GCV value as 44,135.9 kilojoules per kg. Next, we have to write the formula to calculate NCV, which is given by NCV equal to GCV minus 0.09 into percentage of hydrogen into latent heat of steam. So, we have to substitute the values into the NCV formula. NCV equal to 44,135.9 minus 0.09 into 2.5 into 2457. So after substituting into the formula, what we are getting the NCV value as 43,583.07 kilojoules per kg. So the final answer for GCV is nothing but 44,135.9 kilojoules per kg, and for NCV is nothing but 43,583.07 kilojoules per kg. Fourth problem. 0.75 gram of a coal sample containing carbon 90%, hydrogen 6% and ash 4% was subjected to combustion in a bomb calorimeter. Mass of water in calorimeter is 3500 gram and water equivalent of calorimeter is 750 gram. The rise in temperature was found to be 3.2 degrees Celsius. Calculate NCV and GCV. Here first of all we have to write the given terms. Capital W, which is given by 3500 gram, which is weight of water taken inside the calorimeter. Next, small w, which is water equivalent of calorimeter, which is given by 750 gram. Next, rise in temperature, that is T2 minus T1, which is given by 3.2 degrees Celsius. Next, mass of the fuel, which is given by 0.75 into 10 raised to minus 3 kg. So here we have to see the mass of the fuel is given in gram, that is 0.75 gram. We have to convert into kg. So it will become 0.75 into 10 to the power minus 3 kg. S is nothing but specific heat, which is given by 4.187 kilojoules per kg per degree Celsius. Next, latent heat of steam, which is given by 2458 kilojoules per kg. So after writing the given terms, we have to write the formula to calculate GCV, which is given by W plus small w into T2 minus T1 into S divided by M. So we have to substitute the given terms into the formula. So 3500 plus 750 into 10 raised to minus 3. So here we are multiplying into 10 raised to minus 3 because the weight of water and water equivalent of calorimeter is given in gram. We have to convert into kg. So we are multiplying by 10 raised to minus 3 into 3.2 into 4.187 divided by 0.75 into 10 raised to minus 3. So the gross calorific value what we are getting is 75,924.3 kilojoules per kg. Next, the formula to calculate NCV is given by NCV equal to GCV minus 0.09 into percentage of hydrogen into latent heat of steam. So we have to substitute in this formula. So we are getting 75,924.3 minus 0.09 into 6 into 2458. So we are getting NCV as 74,599.4 kilojoules per kg. So ultimately the final answer we are getting as gross calorific value 75,924.3 kilojoules per kg and NCV, that is net calorific value, is given by 74,599.4 kilojoules per kg. On burning 0.85 into 10 raised to minus 3 kg of a coal fuel in a bomb calorimeter, the temperature of 2.1 kg of water in calorimeter was increased from 24 degrees Celsius to 27.6 degrees Celsius. Water equivalent of calorimeter is 1.1 kg and specific heat of water is 4.187 kilojoules per kg per degree Celsius. Latent heat of steam is 587 calories per gram. If the fuel contains 4% hydrogen, calculate GCV and NCV. Here first of all we have to write the given terms given in the problem. Capital W, which is nothing but weight of water taken inside the calorimeter, which is equal to 2.1 kg. Small w, that is water equivalent of calorimeter, is given by 1.1 kg. Next T1, which is nothing but initial temperature, which is given by 24 degrees Celsius. T2, the final temperature, is equal to 27.6 degrees Celsius. Mass of the fuel taken equal to 0.85 into 10 raised to minus 3 kg. S, specific heat, is given by 4.187 kilojoules per kg per degree Celsius. Latent heat of steam, that is L, is given by 587 calories per gram. But since it is given in calories per gram, we have to convert into kilojoules per kg. So we have to multiply by 587 into 4.187, which will give the latent heat of steam, which is nothing but 2457.7. So you have to write the formula to calculate GCV, which is given by GCV equal to W plus small w into T2 minus T1 into S divided by M. So substituting into the formula, 2.1 plus 1.1 into 24 minus 27.6, or we can say it's T2 minus T1, 27.6 minus 24 into 4.187 divided by 0.85 into 10 raised to minus 3. So substituting into the formula, we are getting gross calorific value as 56,746.16 kilojoules per kg. Next, to calculate NCV, the formula used is NCV equal to GCV minus 0.09 into percentage of hydrogen into latent heat of steam, which is given by 56,746.16 minus 0.09 into percentage of hydrogen, that is 4, into latent heat of steam, which is 2457.7. So we are getting NCV as 55,861.388 kilojoules per kg. So this is the final NCV value. Next problem. On burning 0.75 gram of a coal fuel in a bomb calorimeter, the temperature of 2.5 kg of water in calorimeter was increased from 24 degrees Celsius to 28 degrees Celsius. Water equivalent of calorimeter is 0.485 kg and specific heat of water is 4.2 kilojoules per kg per degree Celsius. Latent heat of steam is 587 into 4.2 kilojoules per kg. If the fuel contains 2.5% hydrogen, calculate GCV and NCV. So solution for this is, first of all you have to write the given terms. Capital W, which is nothing but the weight of water taken inside the calorimeter, which is equal to 2.5 kg. Next, small w, which is nothing but water equivalent of calorimeter, which is 0.485 kg. Next, initial temperature of water bath, which is 24 degrees Celsius. T2, final temperature, which is given by 28 degrees Celsius. Next, mass of the fuel taken inside the calorimeter, which is equal to 0.75 into 10 raised to minus 3 kg. Next, specific heat of water 4.2 kilojoules per kg per degree Celsius. Next, latent heat of steam, which is given by 587 into 4.2 kilojoules per kg. So we have to write the formula first to calculate GCV, which is given by W plus small w into T2 minus T1 into S divided by M. So substituting into the formula, so we will get 2.5 plus 0.485 into 28 minus 24 into 4.2 divided by 0.75 into 10 raised to minus 3. So we are getting the GCV value as 66,864 kilojoules per kg. Next we have to calculate NCV. The formula given is NCV equal to GCV minus 0.09 into percentage of hydrogen into latent heat of steam. So NCV equal to 66,864 minus 0.09 into 2.5 into 2454. So what we are getting as the final answer of NCV is nothing but 66,311.85 kilojoules per kg. So this is the answer for NCV value. Coming to the last kind of problem on GCV and NCV. Calculate GCV and NCV of a coal fuel of 1.3 gram in a bomb calorimeter. The rise in temperature of 2500 gram of water in calorimeter was 4.2 degrees Celsius. Water equivalent of calorimeter is 550 gram. The specific heat of water is 4.187 kilojoules per kg per degree Celsius. Latent heat of steam is 2457 kilojoules per kg. If the fuel contains 5% hydrogen, then calculate GCV and NCV. So first of all, you have to write the given terms. Capital W is given by 2500 gram. Small w is given by 550 gram. So one thing I will make it clear, whenever the term is given in gram, we have to convert into kg. That is, we have to multiply by 10 to the power minus 3. T2 minus T1 is nothing but 4.2 degrees Celsius. That is nothing but rise in temperature. Mass of the fuel taken is 1.3 gram. Since it is given in gram, we have to convert into kg. 1.3 into 10 to the power minus 3 kg. Specific heat is equal to 4.2 kilojoules per kg per degree Celsius. Latent heat of steam is 2457 kilojoules per kg. So what is the formula to calculate GCV? That is very simple. That is W plus small w into T2 minus T1 into S divided by M. So after writing the formula, you have to substitute the terms. That is 2500 plus 550 into 10 to the power minus 3. Since it is given in gram, we have to convert into kg. So you have to multiply by 10 to the power minus 3 into 4.2 into 4.187 divided by mass of the fuel, that is 1.3 gram. Since it is given in gram, we have to convert into kg. So we have to multiply by 10 to the power minus 3. So what we are getting, the GCV value is 41,258.05 kilojoules per kg. Next, the formula to calculate NCV equal to GCV minus 0.09 into percentage of hydrogen into latent heat of steam. So substituting the values for this NCV value, that is 41,258.05 minus 0.09 into 5, that is the percentage of hydrogen, into 2457. What you are getting as NCV value as 40,152.05 kilojoules per kg. So I hope the problems based on bomb calorimeter are digested properly and are crisp and clear for the students. So many number of problems are available in the VTU prescribed chemistry textbook. So I recommend students to go through them for better knowledge.